Okay, let's do a projectile problem. We have a baseball that rolls off a 0.7 meter high desk and it strikes the floor 0.25 meters away. And we want to find how fast was this baseball moving. Hopefully it was not an autographed baseball because we need to practice better baseball maintenance. Let's draw a picture for what's going to happen. So we're going to draw in a little diagram. So the baseball starts right here. The baseball is moving like this with an x velocity, and we want to find out what it's equal to. And then this is not drawn to scale. It just falls way down over here, and it lands like this. So let's put in the information that we know. We know that it lands 0.25 meters away, so that's what our delta x is equal to, 0.25 meters right here. And we know that it falls downward 0.7 meters. So that will be our delta y, 0.7 meters. And since it's falling downward like this, we're going to add a negative sign to that. We also know that this baseball is only moving horizontally to start in the x direction. So that means that Vy initial is 0. Essentially, it's no different than if you just to drop this. What we're going to do is we're going to make an x and y table to keep track of all the information that we have. So in the x direction, we actually don't have Vx. We want to find out what that's equal to. We do have the displacement, which is the range, but we do not have the time. There are only 3 variables in the x direction. We don't use a kinematic in the x direction because there's constant velocity. If we look at our diagram, the other thing that we know is that gravity is acting downward like this. And this downward acceleration from gravity cannot affect the x direction because it's perpendicular to that. And we will ignore a resistance for this problem. In fact, for almost all the problems that we do. So we have 2 unknowns out of the 3 variables in the x direction, so we can't use the x direction, at least at first. Let's go to the y direction. Well, we know that the y initial velocity is 0. We also know the height, which is the displacement. We don't need to put the equal sign here, but we know that variable. And we also have gravity's acceleration. So we have 3 variables. There's acceleration in the y direction, so we use a kinematic equation. If we have 3 variables, we can always find the 4th, and we're going to find the time. What you'll notice is that oftentimes it is time that is the link between the x and the y direction. And so sometimes we have to use the y direction to find the time, like in this problem, but other times we have to use the x direction to find the time. Let's make a plan for this one. So what we will do for this, step number 1, is we will use the y direction to find delta t. Then, once we have delta t, we'll use delta t, right? We'll use the time to find our missing variable, which in this case is Vx. What is the speed of the baseball as it rolls off of the desk? So, in the y direction, we have acceleration, so we're going to use a kinematic. So if we ignore the x direction and we just look at the y direction over here, this is just like a one-dimensional problem where we use acceleration. So for step number 1 for this, delta y equals Vy initial delta t minus 1/2 g delta t squared. And for this problem, because we're starting from rest in the y direction, this can just go away. So if we rewrite our equation, we have delta y equals minus 1/2 g times delta t squared. A little bit of algebra. Now we'll solve this for delta t. We end up with minus 2 delta y over g, and then we take the square root. So this equation right here will give us how long it takes for this baseball to hit the floor. Let's put the numbers in. So what we've got is our negative, then we have our 2 times our displacement minus 0.7 meters, and then we've got our 9.81 meters per second squared. Take the square root, and we get a time interval of 0.38 seconds. So this is how long it takes for the baseball to hit the floor. And now that we have this, step number 2 is we can use our equation for velocity, which is displacement divided by time, to figure out what that initial velocity was. So let's put the numbers in. We know from the problem that our displacement was 1/4 of a meter, 0.25 meters. Now we know that we've got 0.38 seconds for the time interval, and we simply get 0.66 meters per second. So now we know that the baseball was traveling at 0.66 meters per second as it rolled off the table. If it was in a case, it wouldn't have rolled off the table. I'll see you in class.